Dr. Mark Yim in mechanical engineering, Dr. Jonathan Beatty in mechanical engineering, Dr. Max Mintz in computer science.
Ryan, do you want to kick things off?
Well, Sam, do you want to start?
Sure. So we start by dumping a couple ball bearings down this little maze, and they'll filter into a cup.
That's actually our first touch. Set in the bottom of here and a little bit pre-weighted is a limit switch. That's going to come to this guy and turn on our 12-volt battery. Flail this, and there's a small copper filament that will pull this out. We have a squash ball that's going to fall down and hit another limit switch. And then what you see here is actually, we had at first tried something totally different and didn't work, so we adapted it. We first tried to do little fingers with this non-Newtonian cornstarch and water in order to wet the tissue paper. I'm going to pass this around because it's kind of cool, actually. You can just try to stab it with a knife.
It feels like a solid.
They call it's called a shear thickening fluid. So basically, you can let the knife sort of fall into it easily, but try to jab it. It's old. It's from yesterday, so it tears a little bit. But so basically, instead what we've done is we just used blue dyed water because we couldn't get enough movement. We could get a nice pattern, but not enough movement. And we've actually funneled to a smaller surface area above the speaker, so we get like basically, you can imagine deflection of a plate this large for a millimeter, and then funnel that down to square inch, and then you're going to get a lot more.
We get a good wump.
Yeah. So that splatters blue water all over this tissue, which lets this steel ball bearing fall down, and yanks this, which becomes yours.
Which starts the chemistry part of this. So basically, here is
A tea bag.
it's full of baking soda, which for those of you who don't know is sodium carbonate. So basically, that falls into this cup, which contains citric acid. It's basically a stronger variant of vinegar, and it doesn't smell. So, so that solution, we made it, nice and safe. It's actually more dilute than we would have needed the vinegar, and so that is basically going to foam because the reaction produces CO2, and that's going to wet that tissue, which is going to make that ball fall over and bring this little piece of paper out here, which is going to have a ping pong ball, which
Then falls into our little nuclear reactor here. So
This is a small scale, well, large scale.
what we have here is a fission simulation where each mousetrap has a ping pong ball on it. So when one ping pongium falls into it, then maybe it'll collide with some of the others, and the ping pong balls will be bouncing off every which way. Eventually, at least one of them will fall down, and so the mousetrap will be.
Okay, and then that mousetrap will throw this string here, and I have a little ball bearing in this cup, and there's a small hole. It was nigh impossible to get a vertical watertight seal, so we're basically just going to have to compensate by pouring the water in like right before we start. But anyways, we're going to have this really awesome toilet bowl cleaner fluid like come down here in this mad sciencey system of tubing and turn this stuff that looks like piss green, and hopefully that will float the boat to signify that we are victorious. So without further ado here, Sam, if you want to fix this, I will.
Probably the last two things to mention are that if anyone's wondering, we're using an Arduino microcontroller to sort of digitally simulate a 20 hertz sinusoidal wave for the speaker, and we'd initially wanted to start this machine by lifting a balloon with electrolysis, which we got to work with Epsom salt and water, but it just doesn't really make enough hydrogen, so.
How many times have you run this?
None.
Let's do it! We run the first half twice and the last half twice.
My hands are shaking way too hard. Can someone else pour this water?
Ryan, can you take it?
Ryan, would you?
I mean, okay. Someone has to carefully start.
Just be like very gentle with the ball bearing. Freaking sweet.
that's good. That's fine.
Sam, if you would.
Okay.
Sam,
Ready?
okay, 3, 2, 1.
John, can you get out?
Oh, come on.
Hold on.
Yeah, sometimes.
There's one more.
Sometimes.
More ball bearings.
It can take a couple minutes.
Yeah.
Okay, I'm gonna skip
Just
the
the
first
first
time.
For the sake of meeting ball bearings.
Okay, so you see this thing moving up and down.
Oh, come on.
Wow. It can take as much as a minute, but like eventually. Sorry, I think initially we had too much water on. doesn't really start splattering very well until a lot of the water is falling off.
But it will work.
It does work.
Oh, there we go. Oh.
Alright.
Yeah. We've had this go like in 2 seconds and in like a minute and a half because it really just is a matter of how long it takes for drops to randomly hit the head piece of tissue paper.
No! I told you that wouldn't work.
It's alright. So that's the citric acid reacting with the baking soda until dissolves that tissue paper enough for that thing to not drop.
Are you serious right now? Why did all this...
Everything failed!
Shake it.
It's alright, you know.
Just put it again. Just put it just for the sake of it.
Is that draining like it should?
It should be draining.
I know it was working!
Remember, you have a second try.
Ryan, just like pour more water into it. I don't think it's got enough pressure. It's supposed to be like a siphoning action, I think is what we basically figured out, but you need like a critical amount of water in there first to start.
We have to overcome the resistance of the tube.
Yeah.
But we didn't need that.
There we go.
More.
It's filling. And it has a flag.
Really what we wanted was just to have the water change colors. And so it has, and that makes me happy.
Yay!